So today we will discuss a very important topic in advanced econometrics, that is panel data regression model. So you have a basic understanding of the different types of data sets that we use in econometrics. One is the time series data and second is the cross section data. And what is time series data? So time series data refers to a data set where a particular case or phenomena is arranged over different time points. For example, if you say we have a data set where you have India's GDP right from 1990 to 2020, it is a time series data because across time from 1990 to 2020, you are recording the data of what India's GDP. Now, this time series can be of different frequency. What in the example we are using an yearly time series data. Time series data can also be what monthly or weekly, or you have real-time time series data where for example if you have stock market transactions per minute or per second, you have what a very high frequency time series data. And then on the other hand, you also have what is called cross-section data, where at a particular point of time data is collected across cases. For example, if you say what is the GDP of maybe South Indian countries, including India, China, Nepal, Bhutan, Pakistan, Burma, or Myanmar, at a particular point of time, 2020, that is an example of cross-section data. Now, another example is that you are 10 students who are attending this advanced econometrics course, and today if I am collecting data from you regarding your monthly per capita consumption expenditure of student A, student B, student C, etc., then that is another example of cross-section data. And when you have a combination of time series and cross-section data, that data set is called panel data. And regression models using panel data is known as panel data regression models. Hence, a data set containing observations on multiple phenomena observed over multiple time periods is called panel data. So it means that you will be having multiple time periods 1990, 91, 92, etc. 2020. So over time. And there will be multiple phenomena. For example, SDP of India, of Pakistan, of Germany, of any different states. So that different countries, that is an example of panel data. Panel data is also known by different names. It's called pool data. It's called micro panel data. It's also called longitudinal data, event history analysis, cohort analysis, etc. What is cohort analysis? See, again, that is across time periods you are studying the case, different cases. Now you are 10 students passing out of your post graduation in 2020. So we are collecting details about your placement in the next year, after 2 years, after 3 years, after 20 years. That is a cohort analysis. So and panel data is used in a generic sense to include one or more of these items. And as I said, regression models based on such data are called panel data regression models. Now, this is the case, this grid shows the case of time series data. Now, for example, over years 1, 2, 3, etc. T, you have data regarding what a particular observation across what x1, x2, x3. That's an example of what a time series data. And then see here you have different individuals 1, 2, 3, etc. I observations on multiple phenomenon observed in a single point of time. At a particular point of time, what is the details of student A? Maybe student A is Sam, then student A's monthly per capita consumption expenditure may be X1, his age level may be X2, his educational qualification may be X3, whether he is coming from rural or urban background is X4. That's for one particular individual. You have what observations. Now for the second observation, maybe second individual, it may be Shruti. Now what is her details regarding X1, X2, X3, etc. At a particular point of time. So only the value of the data points is important here and not the ordering 1, 2, 3, I. Whether it is Sam or Shruti or Gopika or Megha or anybody else doesn't make any difference here. And then if you have a combination of these two, we say that it is a time series data. Now it is a panel data. So time series is often denoted by XT. T is the subscript that you use for time series data, and cross section is denoted by XI, where I is the subscription that you use for what cross section data. And when you combine these two, you have panel data and it is denoted by XIT. That is for the first individual. If it is xi1, it means the for the ith individual in the first time period. If it is xi2, ith individual in the second time period. And data is read as case and time. Example, country, years. So if you say x11, then it can be GDP for India in 1990. X12, it can be GDP for India in 1991. X13, GDP for India in 1993, etc. And if it is X21, it can be, if the second country is Pakistan, we can say it is GDP for Pakistan in 1990. X22, GDP for Pakistan in 1991, etc. And so that's an example. And another examples you can include if XIT is X for a group in months, X for the president, a number, election time, etc. So that's a nomenclature that we use. Now this is a typical panel data set. You can see we are having three countries, Utopia, Lilliput and Troy, and you have data set from 1990 to 1996. So see the Utopia for 1990, what is the per capita disposable income, per capita expenditure and the median household income. Utopia 1991, again the data. So for the country Utopia, you have data for 1990 to 2006. Similarly, for Lilliput, you have 1990 to 2006. So here the time is nested within the country. So such time series panel data is called time nested within what the case. So that's what's written. Time is nested within the cross section in this example. Possible for cross sections to be nested within time. And here there are no missing values. Hence the data set is a balanced panel. And if there are missing values, the data set is an unbalanced panel. Now, advantages of this panel data. It's also called time series cross section data. So what happens here? So if the t is the number of time points and if n is the number of cases, what will be the total number of observations? The total number of observations will be n by t. In one study, for example, if n is 50 cases, that's we are collecting data from 50 students over 20 years, something like that. So what will be the total data points that we have? It will be 50 into 29, that is 17,400. And the ability to model time and space. So if you are using time series cross section, that is panel data, you are able to model both the time as well as space direction and dimension and consumption, and conceptually this is very important. So time series component increases one's ability to show or argue causation. Now the disadvantages is that because you have a large data set across cases this is used, so there is a chance for heteroscedasticity, and definitely the chances for autocorrelation is also there because you are having what time series data, last time period's value affect current values, that is spatial, that is what you have time series autocorrelation across time, and you have spatial autocorrelation because you are having different cross section data. And for example, if this pandemic corona is affecting one country, there is every chance that this effect is spread to other countries. Shock in one country affects neighboring countries. These are the disadvantages. And then this is again written heteroscedasticity, cross case autocorrelation. Now another example, rise in oil prices hits all nations, development aid from one country impacts another country's growth, etc. And so if you are modeling this panel data in a regression equation, this is how you write the regression equation. For example, you are modeling personal expenditure, the equation explaining personal expenditure on household income and per capita disposable income. That is YIT is equal to alpha I plus beta 1 x1 it plus beta 2 x2 it plus epsilon e it. So I said all the subscripts must are written in terms of it, the case and the time. Why it means personal expenditure of the ith person in t time. It can be y11, y12, y13 etc. Then y21, y22, y23 etc. And similarly the household income is also for what? Individual and time. The personal disposable income is also for individual and time. So if you are using cross section, you will only write yi is equal to alpha 1 plus beta 1 x1 I plus beta 2 x2 I plus epsilon I. If you are using time series, you will only write yt is equal to alpha 1 plus beta 1 xt plus beta 2 x2t plus epsilon t. And because you are using a combination of both the cross section and time series, you are using yit is equal to alpha I plus beta 1 x1 it plus beta 2 x2 it plus epsilon it. Now, types of panel analytical models. So you use different types of, now how do you estimate these beta? So what is the purpose of econometrics? It's just to find out the coefficients of the parameters of econometric relations. So you want numerical values for beta, or how is the impact of per capita income on personal expenditure, or what is the impact of household income on what personal expenditure. And how do you model this? There are two types of panel analytical models. One is fixed effects model and the second is random effects models. And let us first study the fixed effects model. Now, even in the fixed effects model, um, there are several possibilities. So the possibilities depend on the assumption that we make about the intercept and the slope coefficients. Okay, these are the four cases that we discussed. One is intercept and slope coefficients are constant across time and space, and the error term captures differences over time and individuals. So we will discuss each one of this and then you will understand it clearly. Second is the slope coefficients are constant but intercept varies across individuals. Third is the slope coefficients are constant but the intercept varies across over individuals and time. And fourth is all coefficients vary across individuals. So we will discuss each one of this in detail. So we need a data set for this. Now you have already downloaded Gretel, and in the Gretel data you will have this Granfell's data set. So please use the Granfell's data set and try to find out the results so that you will have an understanding of how to estimate panel data regression model. So Granfell was interested in finding out how real gross investment depends on the real value of the firm and real capital stock. See, for we can just model it as y as a function of x2 and x3. What is y? Y is investment. Investment is a function of the real value of the firm. The real value means the stock market value of the firm. And second, it may be the fixed capital stock. Investment as a function of value of the firm and capital stock. I hope you understood this. And he was looking into four companies: General Electric, General Motors, US Steel and Westinghouse for the period 1935 to 1954. I think it is 19 years, no, 20 years of data. So what is the T here? You have 20 years, 1935, 36, 37, 38, etc. to 1954. And what is I here? I is 4. And the 4 cases: General Electric, General Motor, US Steel and Westinghouse. So you have 4 cases and 20 time points. So that's the best example of what a panel data, and using this he was trying to find out how real gross investment depends upon the real value of the firm and real capital stock. So this is the first case. All coefficients constant across time and individuals. Disregard the space and time dimension of the pool data and just estimate the usual OLS regression. So here we are using what you have already studied, that is the OLS model. So first you will write the case of what is the first company, maybe that is General Electric. You will say General Electric from 1935 to 1954, what is Y and what is X2 and what is X3. And below the General Electric you will write US Steel from 1935 to 1954. Again the data of Y, X2 and X3. So all these are stacked below. For the four companies you will just write the data points down and you are not combining anything and just running what an OLS regression, and this is the result that you get. So what is the data that you get? You say Y, that is investment, is equal to 0.11 X2. When X2 increases, Y increases by 0.11. 11 per 1 unit change in X2 will increase Y by 0.11, and 1 unit increase in X3 will increase what this Y by 0.30. And what about T statistic? All the T's are significant. And what about R square? 0.75. And what about D? It is 0.21. So 0.21 is nearer to 0. So what about the autocorrelation coefficient? You know, if autocorrelation coefficient D statistic is nearer to 2, there is no positive or negative autocorrelation. And if it is nearer to 4, there is the evidence of negative autocorrelation. And if it is nearer to 0, there is evidence of positive autocorrelation. So the result shows that there is autocorrelation. And so then what is that? The testing, the consequences of autocorrelation, you know, you cannot use it for testing hypothesis. There is every chance that a null hypothesis, true null hypothesis will be rejected, etc. So all coefficients are individually significant. The slope coefficients have respective signs, but the DWD statistic autocorrelation may be due to specification errors. So we have to take into account the specific nature of four companies. Maybe this happens because there is spatial autocorrelation. The four companies may be different. So combining all the four as a single group, this may be the reason for autocorrelation. That's the argument. So now we come to fixed effects model. So here the slope coefficients are kept constant, but intercept varies across individuals. Okay, so it's called the least square dummy variable regression models. It means that across the four companies, the slope coefficient, that is beta, may be same, but the difference lies in the intercept between these companies. That is, the intercept alpha for General Motors may be different from the intercept for Westinghouse, or it may be different from the intercept for US Steel. That's the argument. And hence the model is written as YIT is equal to beta 1i plus beta 2 x2 it plus beta 3 x3 it plus uit. So here see, the intercept is beta 1i. So beta 1i can be beta 11 for the first company, beta 12 for the second company, beta 13 for the third company, and beta 14 for the fourth company. And it's only the intercept varies across individuals. So across time it is not varying. So we are not using T there. So please be very careful. It is beta 1i, which means what? The intercept varies only across individuals or cases. Here it is the four companies. Across time, the intercept, the constant term, the intercept term is constant, and the intercept varies only across only individuals. So the intercepts of the four firms is different, hence beta 1i. The difference may be due to special features of each company, such as managerial style or managerial philosophy. The term fixed effect is due to the fact that although the intercept may differ across individuals, each intercept does not vary across time. That is, it is time invariant. So that is why you call it fixed effects model. Why is it called fixed effect model? Across time, this intercept term is not changing. Across time it remains constant. It changes only across cases. The fixed effect intercept vary between companies is made possible by including a dummy variable for each unit in the model. That is, YIT is equal to beta 1i plus beta 2 x2 it plus beta 3 x3 it plus sigma alpha I uit. That is, we use differential intercept dummies. So you have already studied the dummy variables, where you know how to use intercept dummies and how to use slope dummies. Here we are using intercept dummies to capture the difference among the four companies. Therefore, the equation is written as um, alpha 1 yit is equal to alpha 1 plus alpha 2 d2i plus alpha 3 d3i plus alpha 4 d4i plus beta 2 x2it plus beta 3 x3it plus uit. Now the whole beta 1i which we have used for the intercept is now split into different dummy variables. See, you have four companies, hence you will use only three dummy variables. Alpha 1 will represent the intercept for the first industry, and alpha 2i for the second one company. Sorry, alpha, not alpha, the d2 for the dummy variable for the second company, d3 dummy variable for the third company, and d4 dummy variable for the fourth company. So we can write where d2i is equal to 1 if General Motors equal to 0 otherwise, d3i equals 1 if it is US equal to 0 if otherwise, d4 equals 1 if Westinghouse equals 0 and if otherwise, and if all these are 0, you know alpha 1 will show the intercept for the first company, that is the General Ford, it will show the intercept. So this is how you write a fixed effect dummy model. And then so we have four companies, hence four dummies, and the intercept for it is the General Electricals, that's the first company, it's alpha 1. Since we use dummies to estimate the fixed effects, it is known as least square dummy variable model. So least square dummy variable model is also known as covariance model. X2 and X3 are known as covariates. So this is the estimated result. YIT is equal to minus 245.79 plus 161.572 D2I plus 339.632 D3I plus 186.56 D4I plus 0.1079 X2I plus 0.3461 X3I. So now you know how to write the investment equation for each company. So for the first company, so what was the first company? It is GE. For the first company GE, D2, D3 and D4 will be 0. So for the first company, YIT will be equal to minus 245.79 plus what? 0.1079 X2I plus 0.3461 X3I. For the second company, what happens? D3 and D4 will be 0. So for the second company, you will have minus 245.79 plus 169.1.522 D2I and then about X2I and X3I. Similarly for the third company and for the fourth company. So if you plot the regression, you will have what the parallel lines, because what happens, the slope is same but the intercept may be different. The intercept is different for the four companies and you will have regression, the four companies being plotted as separate lines. I hope you understood. And see, the R square has improved and the D statistic has also improved. So when you work it out for General Electricals, the intercept is minus 245.79. For GM, it is minus 84.22. For US, it is 93.87. And for Westinghouse, it is minus 59.22. See how different the result is from what you have obtained when you were running an ordinary least square. So here you are able to find out the difference in what the performance of investment of the these four firms, these four companies. Now, other than that is captured by X2 and X3. These are different, maybe because of some managerial skills or something like that. So, using different dummies in order to capture the difference in intercept is the first method that we use for panel data regression. It is called what? Least square dummy variable model or fixed effects model. Okay, thank you. Yeah,